Today, we're going to dive into a really bizarre ecological puzzle, one that plays out like clockwork every single 10 years. It's an incredible story of boom, bust, and a 50-year quest to find the tiny, microscopic culprit behind it all.
I want you to just imagine this for a second. Suddenly, everything is covered. I mean, everything. Hairy little caterpillars wriggling across roads, swarming up the walls of your house and covering entire trees in these shimmering webs. This isn't a scene from a horror movie, it's the very real arrival of the western tent caterpillar. But here's the thing. Just as quickly as this massive invasion begins, it stops. The millions upon millions of caterpillars just seem to disappear almost overnight. So, what's going on? What causes this sudden, totally predictable collapse? Well, that is the exact mystery we're going to solve today.
To figure out why they vanish, we first have to get to know the swarm itself. Let's get acquainted with the main character in our story.
So who are these little guys? Well, we're talking about the western tent caterpillar. They're a native moth species, and you can find them all the way from British Columbia down to California. And they get their name from these amazing communal silken tents they build, which are basically these cozy, insulated shelters to protect them from the elements.
Now, this isn't just some weird, creepy-crawly spectacle. These outbreaks have very real consequences. They can strip fruit trees completely bare, which can lead to things like apple festivals being canceled. The sheer number of them can scare tourists away from vacation spots, and they can even be dangerous if animals like horses accidentally eat them. But what's really wild is just how predictable this whole thing is. The population follows this incredibly strict 10-year cycle. You get this slow, gradual buildup for about 6 years. Then, in years 7 and 8, boom, an explosive outbreak. And then, just as suddenly, the population completely crashes in year 9, staying low until the whole cycle just resets and starts all over again. As you can imagine, solving a puzzle that only fully plays out once every decade isn't easy. It takes an unbelievable amount of patience and dedication. And in this case, it became one scientist's 50-year obsession. 50 years. Just let that sink in for a moment. That is the staggering amount of time that one researcher dedicated to tracking these caterpillars, all to solve the mystery of their disappearing act. And that scientist is Dr. Judith Myers. Her incredible journey with these caterpillars started way back in 1972. She was driven by this really fundamental question: what makes animal populations boom and bust like this? And that one single question ended up fueling 5 decades of her life's work. So, after all that time, what did she and her colleagues find? Let's pull back the curtain and uncover the microscopic force behind the great caterpillar crash. This is the million-dollar question, right? This is what drove all that research. What could possibly be powerful enough to wipe out a population of millions when it's at its absolute peak? You know, the obvious answers, like predators finally catching up or the caterpillars running out of food, they just didn't fully explain how fast and how complete the collapse was. The real answer was something they couldn't even see. The culprit is a virus. To be specific, it's a nucleopolyhedrovirus. And here's the key. This virus is always hanging around in the population. But as the caterpillars get more and more crowded during those peak outbreak years, the virus spreads like wildfire. It is, for all intents and purposes, nature's own highly effective reset button. But you know what? Solving that mystery wasn't even the end of the story. Those 5 decades of data revealed another, even more surprising discovery, one that really challenges our assumptions about how insects are supposed to respond to climate change. So the common scientific thinking is that a warming planet is going to throw delicate population cycles like this into total chaos. But after tracking them for 50 years, the reality was just stunning. The researchers found no, and I mean zero, observable effect of global warming on these cycles. They just kept on ticking. So how in the world are they so resilient? It really just comes down to their behavior. They are absolute masters of regulating their own temperature. On a cool day, you'll see them basking in the sun to warm up. But when it gets too hot, they can just retreat into the cool shade of their tents. It's brilliant. Okay, so what's the practical side of all this science? Well, this research isn't just for academic papers. It actually allows us to predict the future and prepare for the next invasion. So here's where we stand right now. The last major outbreak peaked in 2023, and true to the cycle, the population has since crashed. That means the clock has been reset and we can expect their numbers to slowly start building again over the next 6 to 8 years. The countdown is on. And because we can predict the cycle, we can actually manage it.
This research gives homeowners and fruit growers a clear playbook. First, we can forecast these outbreaks up to 3 years in advance. That allows for getting ahead of the curve, like removing egg masses in the winter or small tents in the spring. If needed, there are even safe microbial insecticides that can be used. But the final point is maybe the most important. Don't panic. Remember, nature has its own solution, and that virus will eventually do its job.
And we'll end with this really powerful thought from Dr. Myers, who connects this whole insect cycle right back to our own story. She asks, perhaps we humans can learn about our own adaptability from 10 caterpillars. Are we too defoliating our own trees with a booming global population which the Earth can't support? It's a fascinating question, isn't it? It takes this 10-year mystery and holds it up as a mirror to our own species.